What's up guys, welcome back to the channel. So as a couple of you might have known, a couple weeks ago, maybe a couple months ago, I bought this Mustang Md-250 for $2,500 bucks? It was a $2,500 dyno. I seen one on eBay basically at the same exact time that I bought this for $10,000. When I got this thing, it was in a pit, it was in a shop. It had been sitting for 5 or 6 years. There's a dyno sheet right here from 2017 with dyno readings and all that other stuff on it. So that was probably the last time it was successfully used. Somebody brought the property, they used it for storage, they were gonna rent it out, and they said, get this dyno out of here. That's when Trev came along, handed him 2,500 bucks, loaded on the trailer, brought it down here, and we went to hook it up. Obviously, like everything powered up. Before we even pulled it out of the ground, I flipped all the switches, I turned it on, you looked on here, and we like rolled it with our feet, and it showed like, 1.3 horsepower, whatever, but it wasn't showing any RPM. So right here is a Hall effect speed sensor. So you can see, it has a little sensor and a little toothed wheel. Let's say that's a 100 tooth wheel, and it spins and it tells you the RPM, and this thing will literally do nothing without an RPM signal. As you start looking at it, obviously this is a very old PC setup.
It's like Windows 98, bro.
So
this is like what I played like Minesweeper on as a kid.
It has a Pentium 3 inside. So the dyno is actually from, I believe, 2000. The system is running Windows 98. You can't connect him to the internet. You have a bunch of issues with him. And if you call Mustang Dyno and you say, hey, how much is a new computer stack to fix my dyno or update it or whatever, it's like $7,000 to $12,000. Pretty expensive. And then you were kind of at the mercy of them with their software updates and their things and their stuff. And if the computer goes down, you got to call them and all the other stuff. Started doing a little bit of research on the internet, and I said these things are pretty simple. It's basically a speed sensor, a load cell, and an electronic brake. How hard could it be? I guess it's actually pretty complicated to get them all calibrated and working correctly, but one company out of Poland actually did that. And take a look at this. So right here, in this little bitty box, this box alone, compared to that big giant tower, obviously that thing's not fully used, is this Perek Dyno Controller. It's serious and it's simple, and it's not simple at all. It's very complicated, but I think they simplified the process quite a bit. So essentially, you can see you have all of these little connectors where you plug in something. So it says low side out, low side PWM, engine speed, CAN input, load cell input, analog input, switch input, frequency input, a bunch of things like that. So essentially, if you look on the side of this thing, this is gonna be my USB ports. All I'll have to do is give it power like a regular PC cable. This thing will power up. We essentially run this like a standalone ECU for my dyno. Wow. Obviously, there's a lot of calibration and stuff involved, and you gotta make sure it's wired correctly. The nice thing about this thing is it has a ton of support. I've been going back and forth with Perek about deciding what was the right controller for this. I basically sent him a picture of the dyno. He's like, oh, you need this? Bam, done. It was pretty cool. He asked a couple things like, what is my load cell? And to reuse that. Yeah, so this is the main brain, essentially the computer of it. Then right here, we actually have an eddy brake controller. See, it's got a big heat sink on the bottom of it, but this electronically controls how much basically power or load gets sent to the electronic brakes on the dyno. The next thing that we have is this capacitor right here. It says danger high voltage storage capacitor discharge before servicing. Do you think it's like a 9-volt battery? If you stick your stick your tongue, or you lick your fingers and go.
It hasn't been charged yet.
It hasn't been charged, but maybe we won't mess with that. Here is a load cell amplifier. Okay. So we're gonna go ahead, we're gonna reuse my load cell. That is load cell amplifier. This right here is a new speed sensor, basically a new Hall effect sensor wheel. It's a 32 or 36 tooth instead of the one on there, which is a little bit more, but essentially these are a lot more resistance to noise. Obviously there's a lot of electronic fields going on in there. You got electronic brakes and things going on in that dyno. Lots of vibrations. This is a lot more, it's a lot more accurate. It should work out really good. So you can see here's the little connector set. Pretty much what I'll do is I'll go over to my load cell. See that little pin? See how it has the little screws? You unscrew them. I'll take my load cell, I'll cut off the connector, I'm wiring it, I'll slip them in there, I'll tighten them down, and then I'll come right over here and I'll literally just go plug it. Okay, there's my load cell. And then I'll hook up the stuff with the eddy brake controller, kind of in a similar fashion.
It's literally all just wiring it all together and seeing if it works.
And so we also have a couple of updated things as well. Basically where you put like a piece of tape on like a crankshaft. So if we're doing like a diesel or something like that, you could actually read the RPM off of that. Right. One of the cool things about this is actually Perek, he has worked closely with ECU Master, or I believe he used to work for ECU Master before he kind of went and did his own controller. And that's actually how I learned about this. Is I was talking to Zach from ECU Master. He's the North American distributor. He's like, hey, hit up Perek. Like, we've worked with him before. This is really cool, because I think when he did some training, they used this controller in Poland.
Wow.
Yeah. So that's why, like, Zach was like, hey, hit him up, talk with him. I know this is information overload. You guys want to see this dyno ripping. I'm just freaking excited because this thing is so cool. Even though it's like doesn't look that cool, like the possibilities of this thing are pretty much endless.
And you were telling me that you could even like connect to a car with this.
So that's what I was getting at, is the CAN data out of the ECU Master, you directly CAN low, CAN high, whatever. You literally hook up the CAN bus from like any of the ECUs that I tune with the CAN system. Obviously I tune a lot of ECU Master stuff. All of the data is now in the dyno. So you could log it. You could hook up cameras, just like an IP address camera or whatever, to where like it logs the camera on all the runs. It also has like a fan controller, so it could kick on and off a fan. So let's say if we wanted, you know, as soon as the dyno sees RPM, then it kicks on the fan. Yep. And then it as soon as it reaches 0, the fan stays on for 3 minutes. Super simple stuff like that. So we could have the dyno fan kick on and off. It will probably do more than I'll ever need it to do, but it's nice that you can do that. Look into them. Obviously, hopefully by the end of this video, we have this thing up and ripping, and hopefully making some juice. So sorry that was a little long-winded. I think we're just gonna leave this clip because it's information overload, but it's freaking cool and I'm excited. So let's get to work. So one of the first things we need to do is install this new speed sensor. This one is it's got more teeth. This one has less teeth, but it mounts differently. This one has like a little Allen key and is like, you know, properly machined to fit on that. Whereas there is a little hole in that shaft. So I think what we're gonna do is try to tap that and basically just run a single bolt. And then we have to mount this new speed sensor right there. And then we need to kind of move on and remove some of the other sensors from the dyno, like the load cell and the pneumatic thing, but pretty simple. So yeah, we're gonna start kind of seeing what we need to do. That might be like a custom piece that we need to do, or, you know, drill or tap, or we're gonna figure it out. So we're gonna try to mess with that, and then I think we're gonna start pulling some of the wiring off this thing. That's just the power wire. So now we have this power wire right here. We've unhooked a couple things. We unhooked the load cell, basically disconnected that. We disconnected, there's a little electronic solenoid right here for the pneumatic actuator, for the airbags for the brake. Disconnected that. Trying to decide on how to mount that whole dyno thing. Like, obviously I don't want to just like stick it
on the dyno, yeah.
On the dyno. Like, I mean, technically, like I've seen them, they mount them like in here before. Technically, I could just put a little board right there and just like run wires, and it probably wouldn't be that big of a deal. I mean, we are inside here. There's not like, there's a little bit of dust, but not like a crazy amount. But I was thinking about just doing a little temporary thing like right here on the side, like a little piece of wood.
Okay,
You know, just
so something I've noticed about temporary here at MotionAuto is that temporary ends up being long-term.
Temporary until we get a nice box, and then we'll wire it real nice, we'll organize, we'll tuck the things, we'll bolt it down. But right now, you know,
This is the testing phase.
Yeah, we just need to test it, make sure that it's working before we go full commit on a box. Like I would like, you know, I feel like that would be easier to do too. Just a little piece of wood, mount some stuff to it, just get it going.
Yeah.
Right?
I'm down.
Oh, yeah. We'll get it going. So the next day, we're messing with this thing. We actually realized it's not just like a dyno controller that you plug like a USB into. It's actually a computer. So it's running like a Raspberry Pi type of operating system. And I was like, why does this thing have like a cord to connect it to a computer thing? And then look at that. Oh, buddy, look at that. We got lights. We have a little mini HDMI display thing.
Look at that, Perek Dyno.
Ah, this is cool. Look at that. Dyno, Raspberry Pi. Look at this. Oh my goodness, what is this?
So this looks like just like the software.
Wow. Alright, so the hole is tapped. I centered this bolt right here with a piece of tape. And now take a look at this. Speed sensor.
Looks like it works to me, pal.
It looks pretty aligned. So now the wheel speed sensor is mounted. I feel like I don't have any direction because I don't have a box to put it in. So we have this bend pack box that actually came with the rolling bridge jack over there. I already ordered a little plastic electronic job box, you know, with like a little weather seal and a little clip thing. I just want something to lay it out in. And so that's pretty much what I'm gonna do here is I'm gonna mark out the size of box that I ordered on Amazon, and then we should basically just be able to lay it out exactly how it's gonna be. I'll be able to like screw this down, tighten things, like it should be good, I hope. So drill a hole. Not too bad, huh?
Doing great.
Shout out to the hole saw, being really wholesome today. Low. Right here. Done. Look at that. We have one thing wired. We connected wires together.
We're making progress.
That was a very important step right there. So now we have this guy. We're getting closer. We got the monitor powered in. We have the 220 volt going into it. I need to run the wires for the brake that actually go out to it. Other than that,
we're pretty close.
I think we're getting close. Capacitor's wired. We have the CAN wired. We have CAN system, the CAN low over there. We have the speed signal wired. We have the load cell wired. But really, I think the main next thing that I actually need to do is the brake wiring going to that. But I'm curious what would happen if we just like powered it on to like see what stuff does, you know?
I would say let's wire the brake and then let's see what happens. We had to pull Jamie's car in, and I pulled my car in. Look at this. These are crazy. X5 just getting pelted. This is wild.
It's nuts. Slight interruption with the hail here in Colorado. Man, it's just crazy how literally at least quarter size hail.
I mean, the one that I had was at least, I would say, golf ball size.
It's pretty wild. So a couple big ones, couple smaller ones. That just like came out of nowhere. We were just sitting in here and it sounded like somebody threw like glass or like rocks on the ceiling in here. I was like, uh-oh, we gotta go move some cars. We stopped for that. We're not gonna hook up the brake controller right now just because the capacitor and there's like some discharge stuff, and I don't want to do the wrong thing with that. But as of now, speed sensor is hooked up, load cell is hooked up, the computer should turn on and do all that stuff. So let's go ahead and power it on. I just want to see if we get like a, you know, like a shaft speed, see if we can see if the load cell is actually showing any load, any of that type of stuff. So I think
Power it on.
sit down at my nice little desk here.
Yeah, that's a great desk.
Wait for it to fire up. I just want to see.
Ooh, look at that.
All right, so now we just fire this guy up. Dyno 2. So it has been a couple of weeks, I think 2.5 weeks to be exact, which is actually 2 or 3 days faster than this thing was supposed to come from China. I guess there's not that many load cells here in the United States, especially ones that are the right ones. I ordered one off Amazon. It showed up in 2 days. It was way too big, didn't work. Now we have this one, which should be the proper rating. It is a 1-ton rating. I found the specs on Mustang dynos. The problem is, because it came from China, it's also metric. Since the Mustang dyno is a Mustang,
It's SAE, it's standard, yeah.
standard stuff.
Fancy stuff.
And we're kind of out in the middle of nowhere, and there's like turnbuckles, and then
Yeah, so there are actually Heim joints that actually link the load cell to the platform, the frame of the structure, and then the load cell goes in between, and then another one goes to the load cell itself. But because where we are, we don't have a whole lot of options for
especially
Heim joints.
high quality ones too.
Yeah, since these work and we know they're good and reliable, we could always like go back to Mustang for replacements if we needed to. We are actually going to modify the load cell that we have here. Got one side cleaned up and drilled and tapped and went pretty well, so confident on moving forward.
Yep. So Garrett he's actually he loves this drill press. He is very enthused that I have it. He's like, you know what'd be nice is a drill press. And I was like, you know what, actually I got one right there.
As a matter of fact, this lovely unit could be yours for the low cost of, I don't know, $100 on Amazon.
I think it was like $70 shipped is what it was. It's better than no drill
Better than
press.
not, exactly.
But
so yeah, it made drilling it straight and tapping it straight really easy. So now we can do this one and get it mounted back up into the dyno, and maybe
we could get on the computer and like scale some things and then be like, we got a dyno now. Because I mean, it should be simple enough, but like we're just waiting on things. We've been working on the Evo, we've been working on the Civic. There's just been lots of things. So we're just, we also have a lot of cars that we want dyno too. So we better hurry up.
So basically, since we have the drill press, we're gonna use this to basically square up the hole and everything. Fortunately, got the safety off. I'm gonna line up the load cell itself. I have a stop here that's gonna keep us from twisting if we were in a snag. And I'm gonna bring the drill press down just a little bit and kind of run the tap, or the drill rather, backwards to make sure that we're centered up. Right now the load cell kind of just dance around, do whatever it needs to do to kind of get into a center position. Now with the drill press, or the drill in place, just clamp it down and get to drilling. All right, now that we have our hole drilled, I've got the platform swung aside there. I want to keep it in position where it was drilled. That way, when I line up the tap on here, I know that it's gonna line up exactly where the drill bit was itself.
Oh, so you did that to square it up?
Yep.
Oh, so you're not even tapping it like that. You just use that to get it square.
Everything was clamped in exactly how we drilled it. I only used the drill press to manually start a few threads to make sure that everything was coming in nice and square. So we'll take it off here, move it in the vise, and just kind of nice and easily tap it nice and slow. Not a big fan of power tapping stuff, especially steel, so take it nice and slow.
So now that the load cell is hooked up and working right, the RPM works, we actually have like a dyno reading. Like if you actually spin this thing, it shows you like a little chart. As you can see, like right there, we have engine torque less than 20. That is the highest power that we have got on this thing just with us so far. So obviously we have a lot of calibration and some other things to do. But before I hop on a team viewer with Perek, which he is in Poland, I need to have this thing like a car bolted on here, it's strapped down. One of the next things that we needed to do was actually get, there's a pneumatic brake right there. that actually has airbags to where, you know, you could pull the car on and off the thing. So I'll go ahead and show you that right here. We have this. So right there. So that is the brake for the dyno. So when you pull a car on and off, obviously it locks the rollers so the car just doesn't fall right into the hole. And then also if you were trying to like get a car off of the dyno, it would never get off of the dyno because the roller would always roll. That's the only way to get it off. It's only wired right now for like one way where you have to hold it, but I'm gonna hop on TeamViewer with him tomorrow, and I know there's a setting to just turn the solenoid on and turn it off, and that's essentially all we need. So that will work correctly. Next thing that we need to do is obviously we have the bend pack 4-post lift all set up in the shop. It has these casters, so you know, the thought process is we didn't want to like kill this bay. Let's say we want to drive a forklift in here one day and it won't fit in that door, but we need a forklift in here for some reason. The bend pack lift has these casters right there, which, you know, you stick it right there, lower it down, and then it's on casters. It moves itself completely around the shop. But the problem is then, you know, if we have a car strapped to the dyno, obviously we need to strap it over here somewhere. So I think strapping it to the lift, but the lift needs to be bolted to the ground. So I got these little anchors right here. It's a drop-in anchor. And so what you do is you drill a 1/2-inch hole. You stick this in there. It has like a little plunge, like almost like a little plug right there at the bottom. And you just hit it with a hammer with this thing. So you drill a hole, stick it in there, hit it with a hammer, and then that locks itself into place. And then we will just use bolts to actually bolt it to the ground. Whenever we need to like move the lift for any reason, we just unbolt it. It's flush with the ground. We can move it around, and then we just put it right back in its spot and bolt it again. The next thing that we have to do, we have a lot of things. I have this little clear box. So a little clear electrical box. We are gonna get this thing out of the bend pack box, but I have it clearly marked right there, so everything should fit in there correctly. Lots of things, lots of stuff, but we're getting some work done. So I'm gonna go ahead and get this lift bolted down. We're gonna put a car on there, see where we need to strap this thing. Eventually we're gonna have a dyno, hopefully that is working. We're gonna do some testing, we're gonna do some calibrating, and maybe make some power.
Jesus Christ.
Look how much tension this one has.
I get it, yeah.
So we have it strapped down in the front. I called Brent and I said, hey, how do you guys strap your cars down on the dyno? He said, X in the front, straight in the back. And that's exactly what we did. So got it strapped down. We tried it before, just kind of straight off to the angle in the front, and it seemed like it kind of wanted to do some stuff. We just have it tied to the subframe in the front because there's two beautiful tow hooks. I wish other cars, the RSX is just a nice car to strap down on the dyno.
I'm not going to stand here while you do this. Give me a second.
I know, I wasn't going
Look at that dyno pole right there. I don't think it's calibrated because that graph looks kind of wonky, but it seems like it's stable now.
It feels really stable. And that was 4th gear, like we were probably doing 60, 70 miles an hour. Like,
There you go.
we do this, I think we hit the brakes, and then we calibrate it, and then we can do a pull. What time is it in Poland?
It's 11:59
Midnight.
It's midnight in Poland. There he is.
Oh, he's on.
So anyhow, Perek, he just got online. Now we have the car strapped, or we have a car strapped on the dyno. We have the brake stuff hooked up. I think we need to plug it in, and then we should be good to go. One of the cool things about this, because it's from, you know, the modern century, it's not 20 years old, it has technology. So it's kind of like your iPhone. It has Bluetooth, it has Wi-Fi. So when you have Bluetooth and you have Wi-Fi, you could do a lot of stuff with that. We have one of these little OBD things, and literally, since this is either a Wi-Fi or a Bluetooth connector, we just put this in the dash of the car, and we could connect this to that. So like, we don't have to like run a tack signal to it. The speedometer, like everything just goes over there, which is pretty cool. It also has a CAN signal that you can tie into it like that. He's probably wondering where the brake controller is. Look, he's looking at it. First plug in of the dyno.
I'm gonna stand back just in case.
There we go, plugged in, okay. There it is. So he's kind of checking away. We did some load cell calibration, some like theoretical stuff. So we measured the arm length right there, the load cell, what it is, and now he's messing with a couple things. Obviously they are from Poland or Europe, where everything is like centimeters, it's kilometers, and you can see he went ahead and just switched it over for me to like mile an hour, horsepower and torque, instead of like PS and like Newton meters, because that's like a different language. We don't know that, but now 12 foot-pounds of torque, I know what that is. And then the road speed, you can see 7 miles an hour. We're gonna continue looking at it. So we just measured the diameter of the roller, because it was showing we were doing 50 miles an hour, showing we were doing like 160. So now we're actually gonna test it, get it going a little bit faster than 50 miles an hour, just to make sure that the signal is stable through the whole range.
That's your first autograph.
Yeah. So right now we are just kind of cruising on the dyno right around 35, 40 miles an hour. I have the car at 50% throttle, and he's just like varying the load. You can hear it accelerating now because he reduced the load on it. So he's controlling that thing from Poland, which is crazy. And I'm just holding the throttle. That's it. That's how he's doing all of his calibration stuff. I tell you to stop.
So what's really cool is that he's actually plotting this right now, and you can actually see where he was, and let's see if he goes back to it.
Alright, so that was, I believe, our final run of the day, and we got 142 horsepower and 107 foot-pounds of torque, which they make 190 at the crank from the factory at sea level. We're in Colorado, like there's not, I don't know about like correction factor or any of that other stuff, but I would say that sounds about right, wouldn't you?
Yeah,
like,
I'd say so.
I mean, 140 horsepower, 107 foot-pounds of torque. It's a 160,000 mile K20A bone stock. So I don't know, not bad. It shows that we lost 35 horsepower. I think that's your fault.
My fault?
I think that's your fault, buddy.
Why is that my fault?
Everything's your fault. Everything is Charles's fault. So now that we have the car a little bit more dialed in and we have the dyno dialed in and we kind of know a little bit more what we're doing with it, and I don't think we need to do any like testing, diagnosing, any weird things in here anymore. I think we should be good to seal this whole thing up. And obviously this was my test bed. I drew a line of a box. Garrett went ahead and got this box mounted on the side of the dyno. Really the only thing that I need is, because we use the mouse and the keyboard to control the dyno, a monitor. So all we have to do is run an HDMI cord out of this to the monitor, wherever that goes. I could even team viewer live view in that little PC right there to essentially view the dyno stuff from inside the car. So Garrett is getting that mounted on the side of the dyno. I went ahead and I greased up all the fittings. I'm gonna double check everything is tight right here, lay out some cables, disconnect this whole setup, and then everything is gonna go into the dyno. And it's gonna be a lot cleaner and should be just ready for, it'll actually be a buttoned up, nice looking dyno instead of having extra cords and things everywhere. Everything is boxed up. We have the cover on this thing, which is really nice. It's nice to see it and not be like scared of a big chunk of metal just spinning really, really fast. And then everything is tidied up down here in this box. We were gonna close out the video with it like in the bend pack box. Oh, we'll get to it later. We probably wouldn't have got to it later, so we just went ahead and did it now. Garrett did a great job kind of fitting everything in there, kind of turning it sideways, making sure that we had enough room for the cables and, you know, cable management, all that stuff. Obviously we have an extension cord to plug into this. We have the voltage going to the brake. We have all the sensors, everything tied in here, and then now it's in this nice case. And this is it. Really the only thing that we have to run in here is our mini HDMI cable from our monitor, which we should be able to either put it here or on this old Mustang dyno case. Honestly, I'm trying to sell this whole stack of everything here, so this whole entire piece. You know, somebody old school and wants to fix their old Mustang dyno, I would recommend the Perek Dyno Controller instead of buying this thing from me. But if you want to buy this thing from me, I would like to sell it. I'd like to get it out of the shop, and then pretty much all we need to do is mount the monitor, because we have a Bluetooth keyboard. I want to get one of these with a trackpad on it. So once I have that, literally that's the only thing I'll need to run the dyno is that. And a monitor, which technically I won't even really need a monitor, because I could team viewer from my laptop onto the dyno computer and control everything from there if I really wanted to. So we're gonna get this thing plugged in and do our very first dyno pull on this thing all by ourselves, and I'm stoked. Right here in the dyno thing, it's complicated because you could literally do everything with it, but it's also pretty simple once you learn how to do it. So first thing you have to do is create a project, create new project. You come in here, click the type of car. There's actually an online database. So we'll just go right here and we'll just do car, make. What are we gonna do? Acura, RSX, first generation, series coupe, trim, this one, the big dog. You come right here and you hit apply all. Now you have a project. Look at that. So we have 0 runs. And that literally, it puts in like the drag coefficient, the loss, the mass, the area, like all kinds of stuff, the engine inertia, like just a bunch of cool stuff. Like it's pretty cool. Stock power, stock torque. So anyhow, we already have one created and calibrated to this thing. Obviously, I'm not showing you how to use this thing. I'm just kind of showing you to go through it. So once you do that, then you could click start. Start is very important, because if you don't have a project it's created, you won't be able to click start. But right here, we have an option on the last run. So if we go to absorber off, so that would be just us doing a pull, and the weight of the inertia would just create a dyno pull. And then what would happen after that is we would have to let it coast down from red line. So I would just let off the wheel, put it in neutral, and just let it coast itself down, and it does a power loss calculation of how much you're losing through like the drivetrain, the engine, as well as the dyno. So it does its own little calculation kind of every time you do a pull. Or we could do something right here, which we do torque control. So we have this set up right now. So the minimum RPM that it will start is 3,500, and we could apply a torque 5% or 10% up to 100%, which is 100% of the load that this dyno will make. So the other night we were messing with it, we put it on 20% load, and it was it didn't do anything. And while I was doing it, I was just clicking the button down, and I went all the way down to 5%. That felt like a reasonable load for this car, and it just did a pull and then shut it down. The next thing that we could do is set this up as a speed control or an acceleration control. So what that is set up as is we start at 3,500 RPMs, and it accelerates at 500 RPMs per second. So we could set that to 50 RPMs per second. We could put it at 10 RPMs per second, whatever. We had it at 50 the other day, and it was like super slow. It was holding it all the way back. That wasn't really working. So anyhow, then you could do a ramp speed, which is what we will have to do when we put, like, let's say the 1,000 horsepower Civic, hopefully it makes 1,000 horsepower on this thing. We do a ramped run with that. And what that will do is it will basically stage up, let the turbo spool, and then kind of bring in the load from there, and you could set like mile an hour. You could pretty much do everything with this. It's gonna take me a little bit of time to get used to it, but for the first thing that we're gonna do, we're just gonna go ahead and do an acceleration control, start at 3,500 RPMs, accelerate at 500 RPMs per second, and that's gonna give us a run. So we're gonna go ahead and do that, and then I wanna show you guys the torque control too. I don't know, it's just a bunch of different varying levels control and how you tune the car, what you want the car to do, and really you have to know so much about a dyno, especially a dyno like this, where you can apply load and percentages and RPMs and things like that to really just be able to tune the car and use the dyno the way you want it to do it. So we're gonna hop in the car, turn on the fan. I'm gonna go ahead and warm it up a little bit. So I'm just gonna go ahead and start this run, and we're gonna do the torque control, and I'm just gonna set it at a very low torque, and I'll show you what it does, how it like loads down the car and how it like tries to not accelerate. Could you hear at the beginning of that pull, it was like, it was going fast. I turned the torque control up from 3% to 10%, and it like held it. And then I went back down and then let it go up. And yeah, you can see 148 horsepower, 104 torque. Again, this thing's not fully calibrated. So that was a torque control run. Now we are setting this thing up as an acceleration, so 500 RPMs per second, starting at 3,500 RPM. So I could go ahead and click start on the dyno right now, and you can see nothing's active, and it won't start the run until 3,500 RPM, and it basically does it itself. Well, that's it. We have a dyno, boys. I'm super stoked on this thing. Again, huge shout out to Perek Dyno for helping me out with this thing and like helping me dial it in, and even for the fact that he just makes this thing to make it work. So I know this video is probably a little bit long. We didn't want to cut it short. We just wanted to show you the whole process that we went through start to finish to make this thing work, to doing full dyno pulls and having it basically just done. So the next car that we're gonna put on the dyno is the Honda Civic, and we're gonna see if we could figure out the settings to make that thing work correctly on here. We are revamping that thing in the background, doing some cool stuff. So it should make some good power on this thing. But if you guys like this video, if you know somebody with a shop, with a dyno that's just sitting around, not doing them any good, or they're having troubles with their dyno controller, or they called Mustang or whoever to get a new stack to make their old dyno work, and they got on the phone and they're like, oh, it's gonna be like 7 to 10 grand plus a monthly fee or whatever, have him hit up Perek. And again, he's from Poland, but super awesome. He literally stayed up until 4 o'clock in the morning, like helping us dial this thing in the other night. So link in the description if you want to click on his website, check out his other stuff. Obviously, we're going to be doing a lot more, and I'm not an expert on this stuff yet, and I'm not an expert at tuning, but maybe one of these days we'll get there. So appreciate you guys watching. See you later.